Hi, this is Mr. Aber, and I want to talk to you about advanced ellipses. Well, sort of. I mean, we're just shifting, and we already know how to stretch ellipses, but we need to know how to shift them. And as you might guess, we do that in the same way that we shift circles. I want to remind you that the big idea here is that whatever kind of equation you have, if you want to shift its graph around, you do that in the same exact way. And we do that like so, by replacing x with x minus h, and by replacing y with y minus k. And so instead of x squared, we have x minus h squared. Notice that we used parentheses to make it clear that we're not just squaring h, we're squaring x minus h. And the same with y. In order to replace y with y minus k, we needed the parentheses to make sure that the squared remains here. So let's go to Desmos and see what that kind of looks like. Alright, now I've got an ellipse equation that includes x minus h and y minus k, and I've got sliders for everything. So if I increase the h value, the ellipse shifts to the right, which is actually exactly the same thing that happens when we shift a circle. If I increase the k value, the ellipse shifts upward. Exactly the same thing as with the circle. If I decrease the h value, the ellipse shifts to the left. And if I decrease the k value, the ellipse shifts downward. Really, there are no surprises here, right? So now we've got sort of four numbers that we can play with in the ellipse equation that can put an ellipse of the shape and position that we want anywhere on the graph. We've still got horizontal radius, that's A in this formula. We've still got vertical radius, that's B in this formula. And we have h and k, which shift the ellipse, and about which I'd like to say they also form the center of the ellipse. So h is 1, k is 3, then the coordinates of the center of the ellipse are 1, 3, right exactly there. The center of the ellipse has the coordinates h, k.